Welcome back to CTN. I'm your host, Robert Van Sluten. Let's get started. I've added a pinch and a rotation gesture recognizer to our gestures application. Before I demo it, I want to talk about how to simulate multi-touch in the iOS simulator. If you hold down the Option key, you get the representation of two fingers. And you can move them closer and further apart and actually do a rotation. If you hold down the Shift key at the same time, you can move them as a pair. Let's go to the next slide and we'll actually demo the app. Okay, this is actually more fun on a real device, but you wouldn't be able to see what was going on. If I go ahead and do a rotation with the fingers, the view is rotating. If I move apart, it scales up and scales down. And do a rotation. Of course, I can move it around like I did previously. This will be on the website. Let's go over and take a look at the code. This incarnation of the application is very much the same as the previous one, with some extension and some nuances. To begin with the pan gesture, I'm setting the maximum number of touches to 1 to eliminate any conflict with multi-touch. Probably not necessary. There's the addition of 2 gesture recognizers that are added to our view, the pinch gesture recognizer and the rotation gesture recognizer. And you'll notice that all 3 these gesture recognizers have a different action. In other words, they end up invoking a different method. So there's no decision making as to which gesture recognizer is actually providing information. Now, when any of them start, there is the same notion we had with recording the center, because, for instance, the information is provided based on the starting of the gesture. It's not incremental, so you have to know where you began. And the same is true for the size. What was the size of the rectangle at the point that the pinch gesture started? And we get that out of bounds.size. We've already seen what happens when we do a handle pan. The pinch is based on a scale factor. In other words, when you touch down your 2 fingers and you move them apart, if you move them twice as far apart, you have a scale of 2. If you move them half as far apart, you get a scale of 1.5, or you can go the other direction. And I calculated a new size for the view based on the scale factor applied to the 2 dimensions of the view, size.width and size.height. So in other words, you're changing both directions the same in this particular case. And then I changed the size of the actual view by modifying the bounds. I created new bounds. The origin of the bounds is 0, 0. And the size is the new width and the new height. The rotation is actually simple and complicated at the same time. It's basically just one line of code. Views have a property called a transform, which is actually a matrix, and in linear algebra there's matrix multiplication. These are called affine transformations. And an affine transformation is capable of moving points, scaling the distance between points, and also doing rotations depending on what you put in the matrix. There is a function, CG function called affine transform make rotation, which creates a transformation matrix just simply out of an angle expressed in radians. There's 2 pi radians in a circle. The rotation recognizer provides a rotation value, which is in radians. This function creates the matrix, and then I just set that equal to the transform property of the view. You can dig into this much deeper if you wish. However, all you really need to know is to rotate a view. This is what you would do. This is the whole thing, and we can close out. One closing note is that there was no need to enable multi-touch in the view. Apparently the existence of the gesture recognizers just allow it to happen. It's Perth, Ontario. Thanks for watching.